This is the Spicy 100, question 23.
The recommended time for this one is 5 minutes. I'll read the question to you. Distinct points P, Q and R are on the circumference of a circle C with centre O. The line POR is the diameter of C. Without using circle theorems, prove the angle PQR is a right angle. You need some paper, pen. I recommend using a compass and ruler on this one. So if you've set your timer for 5 minutes, pause the video and best of luck with question 23. So in this question, I think the challenge is reading that information and turning it into a sketch. As soon as you have a sketch, it's a lot clearer what you need to do. So I'm going to cheat and I'm going to steal this circle. So here's my circle. Now I'm just going to grab a ruler and I'm going to draw the diameter. I'm going to start labeling our points. So PQR on the circumference and O is the center of the circle. So I'm going to mark on O, so this is the center. So if POR is the diameter, then that would work. And then Q must be somewhere else on the circle. So I'm going to put it, say, over here. And so what we're trying to show is that PQR, so P to Q to R, is a right angle, but we're not allowed to use circle theorems. So how can we do it if we don't? The trick here is to add an extra line. So if we add a line from O to Q, we can split this into two triangles. This is nice because what we've actually done is we've created some isosceles triangles. So O to P is the radius, which means O to Q is also the radius. So these two lines are equal, which also means O to R is also the radius. So we've got two isosceles triangles, and that's going to be useful to us. So what I'm going to do is I'm going to start labeling some angles. So if this angle, I called it, say, X, then because it's an isosceles triangle, that would also be X over here. If I called this angle Y, then because it's isosceles, then ORQ or QRO would also be equal to Y. So we found some angles here. So what we've got now is this angle here would be 180 subtract 2x. So POQ would be 180 subtract 2x, because the angles in a triangle add up to 180 degrees. We could also do the same here. So I could say that QOR would also be 180 minus 2y. So because we've got the same principle. So what do we know? So the angles on a straight line add up to 180 degrees. So that means then that 180 minus 2x plus 180 subtract 2y. So these two angles here, they would have to add to make 180 degrees. And we've created an equation. So if we rearrange that, we're going to get 360. So if I say 360 subtract 180, so you're going to get 180 degrees. And I'm going to add the 2x, and I'm going to add the 2y over to the other side of the equation. So if we divide everything by 2, you get 90 is equal to x plus y. So you can see here that that must mean, so PQR is equal to x plus y. You can see here, so this angle here is x plus y. So that must mean that PQR is equal to 90 degrees. So thus we have shown that PQR is a right angle. And so we've proved that circle theorem without actually using circle theorems. So that's a nice example. Hope you enjoyed that one. If you're feeling confident, why don't you move on to question 24? And if you're enjoying this series, please do subscribe to the Maths channel. Thank you.